Last couple of people filing in now, so I guess we'll go ahead and get started. Welcome everybody to my talk, Designing a RESTful API Using Spring 3. Excuse me. My name is Ben Hale. I'm a senior member of technical staff at VMware, which is just my title today. Really, I'm a longtime member of SpringSource, one of the very, very early guys. And so I've been a committer on many Spring projects that you guys use. And as such, I am eligible for a t-shirt. I've been asked to let you guys know that if you are contributors to Spring as well, so if you have actually committed code, if you organize user groups, things like that, please stop by the VMware booth, and there's a t-shirt there waiting for you to recognize your contributions. The t-shirt's up there being modeled quite nicely. Beyond that, what do I do today? Primarily I work on commercial products for VMware. So I've been out of the building Spring game for a little while. However, what I do is build using Spring, a lot like you guys certainly will. The stuff that I'm primarily working on these days are RESTful web services, which puts me in a pretty good position to talk today about how to design RESTful web services. So when we talk about REST, the very first thing we need to do is sort of talk about what REST actually is, because certainly there's a lot of confusion when we say something is RESTful. It could mean any number of things. So fundamentally, REST is an acronym, means representational state transfer. No one will ever say that. It's kind of an awkward acronym at that, having to use two letters from the first word. And fundamentally what it is an architectural style designed, for designing distributed systems. And here is where the confusion really lies, is that it's not actually a standard. There is no such thing as something RESTful, right? It's a set of constraints. And so if you have a set of constraints, the level to which you actually meet those constraints sort of determines how RESTful you might be. So it's definitely a continuum between sort of not RESTful at all and what is the ideal case for REST. The constraints themselves, there are a couple of them: client server, something that you understand, stateless, there's a uniform interface. We'll talk about those in a little bit more detail later on. But one of the really interesting things about REST is that it's not actually tied to HTTP. We always discuss REST in the context of HTTP, but because it talks about a set of constraints rather than APIs or interfaces or something like that, it works in anything. You can do REST over messaging systems, for example. However, we most commonly associate it with HTTP. Why? Because the guy who came up with it, Roy Fielding, is also one of the primary authors of HTTP. So in his thesis where he discusses the ideas of REST, he sort of couches them in the context of HTTP. So when we talk about all of the different constraints that REST sort of puts on us, what it means to be RESTful, the most important one, or the one that people get wrong most of the time, let's say, because if we take a look back there, something like client-server, yeah, we all know to do client-server kind of APIs. Statelessness, to some level, every single, these days, every single application maintains state in some very, very low-level database or no SQL repository or something like that. So we know the idea of making something stateless. But the uniform interface is where people get into the most trouble. And once again, in the way all REST is, we're talking about very flexible principles here. No hard and fast rules. So I can't tell you that you are right. I can't tell you you are wrong. So on one hand, nobody's wrong. If you tell me your stuff is RESTful, probably it is. Maybe not as RESTful as you'd ideally want it to be, but you're not wrong. So that's a good start. On the other hand, because there are no hard and fast rules, there is no way for you to say, I am ideally RESTful, right? You just sort of take these principles away. And some of the principles around the uniform interface are this idea of identification of resources, right? How do you identify a resource that you want to do something to? How do you do that something? How do you manipulate that resource? So you need an interface that describes manipulation. The messages that are passed back and forth through this RESTful API need to be self-descriptive, right? And then there's this thing, hypermedia as the engine of application state, which many of you might know is the acronym HATEOAS. I pronounce it HATEOAS, but there isn't really a proper pronunciation, right? It's a horrible thing. We'll go into a lot more detail about what exactly that means towards the end of the talk. So since all of us here realistically are web developers, right? We all use HTTP, and we're all here to discuss RESTful APIs in the context of HTTP. So the first thing we need to discuss then is, what is HTTP's uniform interface? We got the rest of it covered: client, server, statelessness of your interactions and things like that. But HTTP's uniform interface, like, as I said, one of the most confusing bits, what does that look like? Well, if we take that first bullet point, how do we identify a resource? URIs identify each one of our resources. They're basically a unique identifier for a resource that I may want to do something to, right? It's not necessarily required that every resource is represented by exactly one URI. It can be represented by multiple URIs, depending on how you're trying to take a look at this particular resource. But a resource only represents a single but a URI only represents a single resource. Now, how do we manipulate one of these resources? In HTTP, we're actually dealing with a very limited set of operations that you might want to use to manipulate a resource. And this is where people get really, really tense, right? Because HTTP basically gives us the ability to say, I want to get something, I want to delete something, I want to put something, I want to post something there, a couple of other lesser used verbs that you might see in HTTP. But fundamentally, everything that you should be able to do to a resource needs to be covered under these big four verbs, HTTP verbs. And we'll talk about this a little bit later, because many people are going to say, wait, I need to do things that are not get, delete, put, post. How do we do that in a RESTful API? And then finally, how do we make sure our messages are self-descriptive? Headers help us do that. We're going to see a bunch of different headers, but fundamentally what we're saying is, when I pass you a message, I'm going to tell you what the data inside is, what sort of the representation of this resource is made out of. So let's take a look at the verbs. The first verb, get. This is the one everybody knows. It's how you get a web page, right? It basically says, I need to retrieve some information. It needs to be safe and idempotent, which basically means I need to be able to call get as many times as I want, and more or less always get the exact same thing back, not have a whole lot of side effects inside the system. Now, colloquially, we know that get should not have any side effects. Get shouldn't do anything else to the system. All of you who are doing gets with request parameters that then do something behind the scenes, bad idea, right? Fundamentally, a get should be non-mutation, right? However, if you sort of go down into the details and take a look at some of more of the edge cases, get can actually have side effects. If you take a look at the spec, fundamentally what it says, you can have some side effects, but this user is never going to expect these side effects, so they should not be critical to the system, right? So if I call you a get, I don't want you to go delete something instead. That's a bad side effect. On the other hand, if I call get and you create a new audit log entry, for example, that's okay, right? I don't expect it to happen, but if a new entry goes into the audit log, a new resource is created, not that big a deal. I didn't expect it, but it's not going to totally hose anything I'm trying to do. Now, in the HTTP case, get's actually pretty cool, because there are a number of standardized headers that go along with it. So when I call a get, it might be conditional. I might say, I want to get this resource, but only give me this resource if it's been modified since the last time I called it. I might also say, wow, you are a huge thing. You need to ship me a gigabyte worth of data. Maybe I'm only going to ask for a range of that data. I've already downloaded half of it, or I want to display this across a number of different connections, something like that. Why don't you just give me a range of the thing that comes back? And sometimes it makes sense, if you're transferring a whole lot of binary data. Sometimes it doesn't, if you transfer a JSON payload that, is a single piece. So you definitely have some options about what get will do, right? It's very, very versatile. And so we see an example of the HTTP request line that we'd expect to see, get/game/1. Very, very simple. The next simple operation is delete. Requests that a resource needs to be removed. So fundamentally what we're saying is, when I call delete on a particular resource, /game/1, what I want to happen is for that resource to disappear forever and not be available to me any longer. Now, there's nothing that says that the resource actually has to be deleted when you call delete. Right? It just says you are requesting that behavior to happen. If someone returns, for example, an OK response, then there's the assumption that the resource has actually been deleted by the time the response comes back. However, you could in fact return something like accepted. I have accepted your request to delete something, and I'm going to get around to it. Perhaps it means you have to go into the file system and do some sort of big thing. Perhaps you have to notify some sort of back-end reconciliation service or something like that. So removal may actually be a long-running task. And we have ways of telling the caller, yes, this is done, or yes, I'll get to it eventually, kind of thing. So delete is very flexible as well. But with get and delete, the two relatively simple to understand verbs, out of the way, we get to take a look at some of the more complicated ones. In this particular case, we'll take a look at put first. And so put basically says, I want you to take this entity that I'm passing you, so I know your resource, your URI, and I am going to send you a new representation of that resource, and I want you to store it that way, right? So we see an example here, put /game/1/doors/2, and we're going to say, I want you to then take this representation where I have a status of selected, and I want you to now look like this, right? Put can actually be used to either create a new entity or modify an existing one. Creation is actually relatively rare, while possible, because it allows the caller to decide what the ID of the entity is going to be. You can imagine if /game/1/doors/2 didn't exist, and somebody called put, and now all of a sudden there's two. Is that really what you want to happen, or do you rather want to tell it, create me a door and tell me what that door is going to be? So, put basically is a resource should look like this. And finally, post. And I put post at the end because it's sort of the catch-all. If you can't do something that you need to do with the first three, get, delete, or put, post allows you to do something, anything that you want to do. Perhaps you want to create something. Perhaps you want to modify something. Perhaps you want to, for example, start something, right? So the major difference between put and post is fundamentally what is operating on your, or what the request URI is actually representing, right, where the operation goes. So when we took a look at put, we said, you resource need to be modified in some way. On the other hand, this says, you resource need to do some work for me, right? So /games, when I post to /games, I don't want games to look like what I've posted. What I want it to do is do some work, right? And then let me know how that went for us. So we're going to take a look at a demo here. This is a game from the US called Let's Make a Deal. Many of you may have actually heard of this as the Monty Hall problem. And so the Monty Hall problem is basically this. Given 3 doors, come on down, let's make a deal. What I want you to do is select a door. We're not going to open it, but we're going to select a door. Oh, here we go. I've selected door number 2. And now the host stands to the side and says, oh, I forgot, actually, I should take a step back. You guys probably don't know why you even want to select a door. So fundamentally, behind one of these doors is something great. In the TV show, it might have been a new car, right? Something like that. And behind the other 2 doors are something that's not so great. Maybe some dishwasher detergent or something like that. So what I want to do is I actually want to find the door that is a car, right? So select a door. I selected door number 2. The host comes over and goes, you sure about that? I say, I think so. He goes, tell you what, I'm going to open one of the other doors, and I'm going to show you what's behind it, and then I'm going to let you choose again. So we open door number 1. In this case, we have a small furry animal, my cat Loki. So with a name like that, I'm sure the demo will just go absolutely great. No mischief at all. And so he says, okay, so now that you know that one of those doors had a small furry animal behind it, the other one has a small furry animal behind it, and one of them has something really, really good. What do you want to do? Still want to open door number 2? Or, I'll give you the option, do you want to open door number 3? Anybody have a guess? What you're supposed to do? What's that? Always switch the doors. There's a whole lot of math that's taken centuries to prove kind of thing, but you always switch doors, fundamentally. So we go to door number 3, and what do we win? We won Jürgen Höhler, right? The greatest thing any Spring developer could want. You can ask him any question you want, like, why is Platform Transaction Manager so bad? Code, not the implementation. The code is just, it's horrible. It's not up to, what you want. So anyway, so we've won. So this is the game we're going to play. And it's not very, very hard, right? We'll take a look at the user interaction, but this is a relatively simple game. You'd think designing an API like this would be good. This game was used as the keynote address at Spring 1 a couple of weeks ago. And I was working with Adrian Collier, the CTO of the SpringSource group and founder of AspectJ, if you guys know that. And we must have spent days trying to figure out what this API should look like, which kind of gives you an idea of how hard it is to design a RESTful API. What do we want to do? And the reason that it took so long is it's important to know what the user interaction model with your API is going to be. There are many different ways that are right to design an API. But if you know what your API is supposed to do and how people are going to use it, you can really do some optimizations to help them out with that. So let's take a look at the interaction model. Create a game, list the current state of all the doors, select one of those doors. The game will open one of the other doors once I've done that selection. That other door obviously is not going to be a winning door. Then we are responsible for opening one of the other 2 doors. We'll list the outcome of the game, whether you've won or lost, and we'll clean up the game at the end. So when we create a game, the answers are all going to be on here, but I want you guys to think about that interaction model, right? When we create a game, what we're talking about is we want to have a single well-known entry point. This is something that most non-RESTful APIs certainly, but also a lot of RESTful APIs miss. That from the perspective of a user, having to know more than a very small number of entry locations really tightly couples the client to the server, right? It makes things very, very brittle, a very tight coupling between client and server, which is not what you want. You didn't choose HTTP to make sure that they had to communicate with one another, because there are much more efficient principles for direct, tightly coupled communication, right? Sorry, more efficient protocols, right? Sorry. So HTTP and client-server interaction mean we want a loose coupling between these two. So we want to basically say, if ideally, here is a single URL that you need to know. Given this single URL, you should be able to get everywhere else in the entire API that you need to. And we're going to discuss how you do that. But we want to create a game, single well-known entry point, doesn't require any input, right? Maybe if you were expanding this a little bit, you might say you want the user to give them your name or something like that so you can display it. But in our case, all we want to do is say, post games, right? We want to be able to say, create me a new game, and then when that is done, and here is the key, we want to return the resource identifier of the newly created game, right? So basically say, create this for me and tell me where I can go get it. Given that returned game, let's list the current state of all of those doors. We need to return a collection. So we'll say, get games/0/doors, return me an array of all of the doors and their current statuses. In this particular case, they're all going to be closed. One of the keys that I think, certainly in our first couple of iterations of designing this API, is it's very tempting to say there must be a door number 1, door number 2, and door number 3. And the truth is there doesn't need to be. Each one of these things is represented as a resource, so it is uniquely identifiable. An array of doors, since each one has a unique identifier in REST, is sufficient because you'll always be able to map back, exactly which door you're working at all times. Doesn't matter which order they're displayed on the screen, so long as it's consistent, and when you choose one, the request goes back to that one. Somebody smell hamburgers in here? There's no HTTP verb called select, right? That's the next step that we need to do. How do we represent the selection of a door? And I would say this is definitely where most people sort of get caught up and have trouble, is these verbs that don't necessarily match what the server gives us. And so traditionally, this is done wrong. But the easiest way to take a look at this is say, what is the action actually trying to accomplish? When I select a door, what am I trying to do? And fundamentally, in our case, what that is change the status from closed to selected. So to do these verbs that you don't think HTTP can do, what you do is you manipulate the resource and tell it, here is the state I want you to be in at the end, right? I want you to be in status selected when I call put. And what happens behind the scenes? Who knows? Server does all sorts of stuff, right? Maybe it manipulates it. Maybe it actually goes back to the back-end game engine and selects that door, triggers the next operation to happen, and then we go and list what happened to all of the doors once again. So that's key, right? This is probably the hardest thing that people have when designing HTTP REST APIs. Like select, we want to request a mutation once again for opening a door. And we don't need a second API for this, which is another place people go kind of wrong, is that they have just a huge explosions of API for every possible thing they might want to do. So in our case, we just need to mutate the status again, right? In the same way we were able to take a door from closed to selected, we can also take a door from closed to opened at the end. List the final state of the game. We need another getter, and it's going to give us a status of won or lost, obviously. If we've lost that, pretty simple, straightforward get. And then we destroy the game. No input required, no output required. And so we'll just call delete on that. So everybody kind of has an idea of how this game is supposed to be played, right? Good, because now we're going to... I often wonder if the fact that I feel like a fraud up here comes across. Because what I'm going to show you is, certainly the first bit of this, is nothing new. If you guys are Spring users, if you guys have been using Spring 3 MVC, so like the add MVC stuff, this is all built in. It's not well understood how you might design this, a RESTful API, but nothing I use to begin with here is going to be particularly off the wall. So, standard application, as you guys would expect it to be. I'm going to skip over a lot of stuff. Suffice to say that behind the scenes there's an engine that knows how to trigger all of this. We're going to make some calls too. And I've got a couple of partial implementations of things. So we'll start with a controller. In this particular controller, we're going to map it to /games. That's where we're going to start. And we need to do some things. So the first interaction we said that we needed to do was, how do we create a game? So behind the scenes, we're going to say a method, response entity, and we want to create a game. Right? Okay. So we need to say that it has a request mapping. Now, I like to take a look at our request mapping as if I was reading an HTTP request line coming left to right. So I might say to start the method this method should be post, right? And the value, so the URL basically that I want to connect to, is going to be empty, right? Because we have /games that we're going to inherit from the top of the controller. So at /games, if you posted to /games, what are we actually going to do? And this is an example of how post works, right? It's not manipulating the /games resource particularly. What it's actually doing is some sort of operation behind the scenes. Now, obviously, the value equals empty is a default and things like that. Feel free to use the defaults, but as I said, I like to be able to look at this method and see method, request method, so I want to post to X, right? So we'll make some calls. We create a game. Game repository, and we create. Now we want to return I'm going to put in an HTTP status code of OK. We'll talk a little bit about HTTP status codes in a second. Sorry. Don't pass the game through. That's my bad. OK, so now we'll go ahead and give this a run. And let's see. So I'm using something called the Spring Source REST shell, which just makes it easy to do things. So we'll go ahead and come in here, and we'll say, so we'll change from the base URL that it's deploy that to games, and we'll say post to games. Tells us, okay, posted to /games, we got a 200 OK back. But what we haven't done is communicate to the caller where to go get that game. What's the resource that I can now take a look at, now mutate? So we're going to do it a little bit differently than that. So what we need to do is put in a header. And so a specific header, the location header, it's one of these well-known standardized headers. It basically says, if this header comes back, you know to look in this place. It's used pretty commonly. In this case, we've created something, goes out there. If you had something that you were going to do a long-running task, location generally is passed back to represent some place that you can go look for the current state of the task and find out when it's completed. I am going to gloss over the API that I'm about to use called link to. We'll talk about that in a bit, and you're going to see that exception pop up quite a bit. I'm using a very cutting-edge version of the STS suite at the moment, so forgive me for that. But basically, this API will allow us to say, a URL / a particular URL, and then turn it into a URI. So now, hopefully, and then we'll go ahead and pass that through. Now, hopefully, if we create a game, we should see that it hands back. Oops, need to restart that. We should see a location header come back that tells us, okay, I created you a game, and here it is, /0. One of the things I really like about the REST shell is, since most of the time when you're creating something like this, you can actually say follow true. Right? And it follows us to the one that was actually created there, straight to games form. So we've got a get for that. We might also want to now show a particular game. Okay. In this particular case, we want to return a game itself. What does our request mapping here look like? Once again, get, and the value we want to get is going to be /game ID. So if you aren't familiar with what Spring MVC can do for you, you can basically take this curly brace name and map that as a path variable back into the invocation of your controller method. So now we can just dissect the URL that's being called and say, okay, here's an ID for you. I can never remember what my API actually is. And we'll go ahead and allow the exceptions to get thrown out of here. Okay. So now we'll go ahead and restart this, and now we should be able to take a look at what's actually returned. Actually, before we do that, we have to do one other thing. So if you remember, I talked a little bit about the messages that are sent back through a RESTful API need to identify what is actually being sent out. Right? So we're handing back this game, but this Java object called game is totally useless to the caller. We don't even know if it's Java on the other side, right? It needs to be turned into some representation that the caller can actually understand. So in this particular case, what we might say is that we want to produce what's a media type? That sounds good. Application JSON. So what we're actually going to say is, this thing is going to produce JSON. And that does, it's setting this produces bit of the annotation, allows us, or allows Spring to know what I should convert this particular thing to. So it basically says, when I get this game object, I want to represent this game object as JSON. It's taken care of sort of in the plumbing of Spring for you, and make sure that it gets back out to the user as that. In addition, it puts a header on that response that tells us, or that tells the consumer what exactly they are getting. So 0, and now we should be able to say get. And you'll notice this time that we have a content type of application JSON. So now the user, without knowing what they were going to get, they basically said get. I don't care what I get. We'll tell them what it is. And it might be JSON, it might be XML, but it gives them enough information to then take the body of that entity and turn it back into something that they understand. They know this is JSON, they can parse it as JSON and do something interesting with it. We know that there is one other method that we need to implement as well, and that is the door modification, right? This guy's a little bit more interesting. So in this particular case, we want to say modify a door. If I can learn to spell here. Why am I finding it? We'll need to know the door ID as well. And we're going to do one final thing here. We're also going to say, we want you to map the request body to something. In this case, I believe it's string, right? Yeah. This tells Spring that before you give this to us, before you give us this request body, we want you to take the thing that was passed to us and turn it into a map. Now we'll take a look at the request mapping. Wow. Method. Anybody remember what modification of a door was? What request method we used? Shout it out. To put, yeah, absolutely. Because we basically want to say, here is the new state I want this entity to be. Game ID, doors, door ID, not request mapping, how about that? But now, how does Spring know how to turn what is effectively a bunch of bytes into this map that we want? So now what we have to say is, we expect someone to pass us some type. And it can be a number of different types. Once again, it might be XML, it might be JSON. And Spring knows behind the scenes basically to do some negotiation to find out what it can turn it into and run something automatically. So we're going to say this time that this method actually consumes application JSON as well. Now, let me put in a whole lot of code here. Oh, there we go. Passing in the body, so we have this thing that knows how to take this map and extract status from it, go and get the game that we want. And now here's the interesting thing. We know that we actually need to do two different behaviors here, right? We need to be able to select a door. We need to be able to open a door. So if the status that's passed in is selected, go ahead and use the game and select a particular door. Else, if it's open, we want to do something else. If it's something because you've passed to something, who the hell knows what it is. get a little shirty about it and say, no, you are not allowed to do that. Okay. So there's a ton of exceptions that are going to get thrown out of here, and we'll take a look at those in a second. Okay, we'll start this up once again. Posted it, and we go ahead and call get, and we get something back, okay? Nothing's really changed. But now here's an interesting question, right? Suppose you request something that doesn't exist. So suppose we instead say get, instead of get 0, which would return what we expected, what happens if we ask for something strange? Boom. Stack trace, you'll notice down at the bottom there's some HTML. For those who are not familiar with it, this is the HTML page Tomcat gets you when it has no idea what it's supposed to do. Unfortunately, totally useless to a REST API, right? I asked for JSON, basically, or I was more or less expecting JSON, and I got HTML, not useful at all. So how do we handle that, right? How do we handle exception cases? So that's next. And the answer is status codes. HTTP provides us a way to inform the user, right? Inform the caller what happened just now. We've seen a couple of them. We've seen created, we've seen OK. Broadly, these things are divided into a couple of different categories, right? 1, informational, 2, successes, 300s are redirection, 400s are client errors, and 500s are server errors. And we'll take a look at a couple of the common ones. 200, okay, the one everybody wants to see. Nothing went wrong, everything worked. 201 created. The server has successfully created a new resource, and it is generally considered a good idea at this point to return the newly created resources location in the location header, which is what we did. We also have 202 accepted. The server has accepted the request, but it's not yet complete. It might be a creation that takes a while, it might be a deletion. It's not required in this particular case, but it's common practice to say, here is a URL in the location header that you can go and get status. So you might poll against that for status. Alternately, if you are sort of starting up with WebSockets and things like that, maybe you tell them how to connect to your WebSocket endpoint and start pushing them status updates rather than having them poll the server. A lot of stuff you can do there. Client error status codes, 400 bad request, one we've all seen for sure. It basically means that what you have done with your request is malformed, and you should not try it again because it's never going to work. Make sure that you modify your request in some way. Put a new payload inside of it, hit a different URL, give me a different structure to it or something like that. But whatever you do, don't keep trying. This is just never going to work. 401, unauthorized. I throw this one in here. It irritates me because it has absolutely nothing to do with authorization. It actually has to do with authentication instead. And it basically tells you that you need to authenticate to access this API. So it's not within really the scope of this talk, something more advanced maybe. But there's a handshake where you make a request. It tells you you're not authenticated and how you might authenticate. You go back with the authentication credentials that you need and the request is serviced. But it's pretty common to see that. 403, forbidden. Server understood what you asked for, not going to do it, right? Don't repeat because it's not that you've given me bad data. It's just, no, this is not something I'm going to do for you. 404, not found. You're asking for a URI that I don't have. 406, not acceptable. Behind the scenes, in a RESTful web service, you'd hope that there's a content negotiation going on. The client tells the server what is acceptable and sort of your preferences. I can handle JSON, I can handle XML. The server gets this, sort of negotiates and says, okay, here are the things you want, here are the things I know how to do, and I'm going to hand you back the one that you prefer the most, ideally. However, it's possible that that negotiation fails. What the client can handle and what the server can handle may be two completely disjointed sets. And therefore, we might just say, sorry, I can service everything that you want to do, but what you've asked me for back, I can't give you, so I'm not going to service this request. And the final one we'll talk about, 409 conflict, is basically saying everything has matched up properly, but the state of the resource that you're trying to operate on is such that I can't do this, right? Something's in conflict. So maybe opening a door that's already open in the context of our demo app. The exceptions that we saw, this gigantic explosion of HTML when I'm expecting JSON back, and do something useful with it. So Spring actually gives us a way to do that, what are called exception handlers. So it is possible for us to say, come back to this in a second. We actually want to return a not found instead of an OK. And when do I want to do that? And door does not exist exception. So now basically what I'm telling Spring to do is if a game does not exist exception or a door does not exist exception, so you're basically asking for a resource that I don't have, if any one of those are thrown, automatically map that to a not found, right? And that might be good enough. It may be good enough just to get a not found back. But not found, what's not found? I'm unclear what's not found. Is the game not found when I ask for a door? Is the door not found when I ask for a door? What exactly is going on here? And this is another place that people don't realize what you can do. Just because you've gotten a 400 something back, right, doesn't mean that you can't also send a body. So it's very common in a REST API to also give some context around this. We'll do something really simple and just basically put the exception message in there, right? Let's handle all the other kinds of exceptions that we might have. Never, ever, ever copy and paste, right? Bar request, I could use one of those. And what might cause a bad request? There's a couple of those. Illegal argument or a missing key exception. So basically, you've given us a status change that you want done and there's no key in it. This guy will be handle conflicts. You've asked for a transition that is not sufficient. It's not allowed. And this guy is, I believe it's illegal transition exception. Good. So now, let's go ahead and redeploy this. All right. So we have created a game at 0, but now what happens if we ask for something that doesn't exist? Boom, right? Much more easily readable. In our particular case, it even gives us a message. You asked for a particular game that doesn't exist, right? You might ask for a game that does exist, but a door that does not exist on that particular game. So we're now providing some context back. In our case, we slapped in a string. You could put a JSON payload in there, for example, if you wanted to do something like that instead. All right? So that's how we handle exception cases. But now we've got a problem, because if we do actually say get 0, how do we know where we want to actually change doors, right? How do we know the URI that I need to modify, that I need to do a put against so that I can do this? And this brings us to HATEOAS. What is HATEOAS? Hypermedia as the engine of application state. Fundamentally, to enforce this loose coupling that we want, a client shouldn't have built-in knowledge of how to navigate and manipulate the model, right? It's very common. Every REST API document you've ever seen has every single URI you might need to call. But it means they can never change those URIs, right? If they need to structure something differently, they're out of luck. They've got a published API, they have to deprecate, they've got backwards compatibility issues, things like that. All crap, right? Tight coupling is bad. Instead, the server needs to provide that information dynamically to each user who's trying to use this API. And so we implement this sort of hypermedia as the engine of application state using media types and link relations. And if you've ever done any HTML, if you've ever put a style sheet ever on an HTML page, you actually already know how to do this. So a resource can be represented in different ways, as we said. It might be JSON resource, but the same resource might be represented as XML instead. And Spring behind the scenes, as I said, knows how to do this content negotiation and automatic conversion and things like that to build all this stuff for you. The client doesn't know what the server is going to send it. The server doesn't know what the client is going to handle. They're going to negotiate with one another using accept headers and content type headers. And obviously, content type header is useful when you're posting or pushing as well, so you can tell the server what you're sending it. And all of this stuff sort of goes together in this idea of content negotiation to make sure that each side knows about the message. It's just this self-describing message requirement that we talked about with REST. And the more interesting bit of it, link relations. As we said, the client can't be required to know where a door is, so the server describes this as part of the payload. A link. A link has two sort of required parts, although, again, there is no standard around this. This is more sort of accepted de facto standardization. A rel, what the relation actually is, and an href. So the rel values are standardized. And when I say standardized, I don't mean at the W3C or something. I mean, you and your client agree on standard things. So now, instead of describing an API as a list of URIs or URI patterns, instead what you're saying is, my API is if you are at a game and you can ask for a link to the doors, right? You can say, I go through this complete set of links that gives me a bunch of different stuff, and the doors link is what I need to use. So it's completely opaque to the user what that URI is, but it does give them the information that they need. And in HTML, as we've said, if you've ever done a style sheet, link, rel, href, and JSON, the accepted practice is rel, href, exact same information set on both sides of those, both types. This is the first time I'm going to talk about something that you guys probably haven't seen. And this is Spring HATEOAS. So Spring HATEOAS is basically, sorry, let's go back to this side, is basically an attempt to help you do this kind of stuff, right? We know that you want to have this hypermedia as the engine of application state. How can Spring make it easier for you to do that? And so we have some implementations of this. So in this particular case, we need to create a game resource. Now, one of the things that you find out when you're dealing with REST APIs is you have this domain model, and so far we've been passing this domain model straight through, right? We've passed this game all the way out, but it doesn't have enough information. Now, what do I decorate with a link, right? Do I want to decorate my domain model, which has nothing to do with the web, with something that's very web specific, or do I create sort of a DTO around that? And in this particular case, that's what we're going to do. We've extended a base class called Resource Assembler Support, and it basically knows how to instantiate one of these game resource things that we have that contains all the information, and we can build one of those. So, game resource. Is how to take a game and create me a game resource from that. We can say that it has a property called status, which we get from the game. Get status, sorry. I've been doing too much JavaScript lately. And we want to add a link to it. And this gets us back to that API that I ignored earlier, or did not talk about. Spring HATEOAS makes it very, very simple. And it basically says, given a controller to figure out what the beginnings of your URI are supposed to be, I then want to create something that is slash, that URI slash game. And I want to create with, oh, sorry. We need to make a link from there to doors. Now we'll have a link for how to get to doors. and we want to say that its rel is doors as well. Go back to our games controller, and instead now of handing back the game directly, I'm going to hand back a game resource instead. Given the game, create me a resource, return that resource, and now hopefully we should see something a little bit nicer. What do we see here? Among other things, we've sort of hidden away a lot of the internals. You probably could have done that, or we're using Jackson to do this, so there's all sorts of annotations to ignore some stuff. But now we're only sending enough information for you to use. So we have the status, we're awaiting initial selection, but we have a collection of links. It is generally considered best practice to have a self link at all times that basically is, here is my unique identifier. Self is the accepted name for this. But we also say that if you need to list the doors, use this URI. It means I've never had to tell anybody what that URI is. You can simply say, oh, I know I need the doors. Let me go look up how exactly I get that. So we should be able to say, so we can discover all these, so we can then say follow to doors. Boom, something bad happens there. Oops, let me do some more coding. We need one more thing here. The door resource actually needs to be implemented. We used the base class for the door resource assembler before. You don't have to if you have something that needs to be created a little more complicated way. So this time what we're going to say is a door resource. We can just instantiate it ourselves. We can get the content of that particular door. And we can add a link again to it. In this case, we're going to want our self link, obviously. So link to. Door, and then with a self-rel. So we need to create a self-link for it because everything that comes back should have one of those, and we'll return the resource. So created it, moved to it, discovered what we can get from it, follow to doors. And now we see that doors returns us a bunch of doors. You see there way close to the top. It says doors, and it's an array, and each one of those doors is this door representation that we see. And each one of those, you'll notice, in its representation has a self-link as well. This is our unique identifier. So given this, I don't need to have a door 1, door 2, door 3. Instead, what I can have is, here is a collection of doors. Each one of them has a unique identifier. It's completely opaque. You don't need to know what it is, parse it or anything. You know that this will always be the same for each door that you want to do. And then we can do all of the posting that we need to do, all the putting, getting, and things like that, based on that information. So I'm rushing a little bit here at the end. So we've got an implementation. But now that we've designed and implemented, can you actually use this API? We've got a set of goals. We need to hit a single URL to start the game. We want to traverse links to get to all the pieces that we need. We want to negotiate what kind of content we want back and forth. So why not introduce some Python in a Java session, right? So the script that we're going to take a look at is this right here. It's got a lot of code sort of below the fold, but the key thing I want you to take a look at is there is exactly one URL in here, right? You're never going to see another URL anywhere in the listing of this entire thing. We get link location, so this is basically a hunk of code that we go through to extract a particular link from a collection of links, so I know that if I need a door, I can go here to get it. If we take a look down here, how does it work? We create a door. We create a game right here. We get the link location for all of the doors. We get a particular door. Actually, we get all of the doors. We print their current state out to the screen. Then we do a put to do a selection right here. That's what we're seeing, and you can see that we have our payload status selected and our headers content type. We get the response back, and so we print the current state once again. We do an open this time, and we print everything out and then delete the game. So now, if everything works right, let's make a deal. Okay? We'll go ahead and open door number 1. We see that it's open. Door number 2 was selected. Door number 2 is a small furry animal, and it is open. So we'll go ahead and open number 3, and we get Jurgen, and we win! Congratulations, everybody. You're all winners today. So yes, given a language that knows nothing about Java types and knows nothing about the single primary URL, using simple link traversal and things like that, and content negotiation, we are actually able to consume this particular API. So the roundup. API design matters. So the roundup. API design matters, right? It seems like a long time ago in the context of this presentation, but in the beginning I said it took us a long time to design an API this simple, and it absolutely does matter. URIs represent resources, not actions, so you're talking about nouns, not verbs. HTTP verbs are general but can be used in ways that make anything possible, whether it's selecting, opening, or whatever business operation you need to do. The implementation itself isn't rocket science. Spring MVC, if you know it, you can already do this. I encourage you to take a look at the very new Spring HATEOAS project for helping create links and things like that. It has some other nice little RESTful toys in it as well. And so that gives us Q&A. Oh, obviously, you guys can see on the slides, all of this code, the slides and the code for this presentation that we used is published on GitHub, so feel free to fork or download whatever clone that you'd like to do. Okay? Thank you all, and if you have any questions, just go ahead and meet me up here, I think is the best thing. Thank you.